NCERT Physics Class 11th, 5th chapter, which is motion in a plane, question number 5.34. So in this situation, we have given two bodies of mass A and B of mass 5 and 10 kg kept on a table against the rigid wall. The coefficient of friction between the bodies and table is equal to 0.15. Force of 200 Newton is applied horizontally to A. In first part, is asking about the reaction of the partition. What are the reaction of the partition, that force exerted by this wall on the system? So first of all, a force of 200 Newton is applied on the block and the friction tries to oppose it. So the friction will act its maximum value and try to prevent it. If the force of friction is less than 200 Newton, in that case, wall has to exert a force in opposite direction to prevent the motion of block. So let's say this is block A and this is block B. And this is the wall which is at here. So first of all, we are going to find out the force by friction. So frictional force is equal to mu s into n1 if this normal is n1 and this normal is n2. So on block A, the frictional force is mu s into n1, and block B, the frictional force is equal to mu s into n2, and both will act in opposite to external force 200 Newton. So net frictional force comes out to be, mu s is common, n1 plus n2, and n1 plus m2 comes out to be 50 plus 100. Putting the value of mu s is equal to 0.15, we have net frictional force that is equal to 22.5 Newton in left direction. So frictional force comes out to be 22.5 Newton in left direction. Now moving to next. Now from this we can say that friction is not sufficient to prevent the motion. So the wall has to exert some force on this. But the system hold at rest, so net force is equal to 0. We can say that F net is equal to 0. This implies that if the force exerted by wall is F1, so we can say that F1 plus frictional force that is equal to 22.5 is equal to 200 Newton. So from this we can say that force exerted by the wall on the system can be written as 177.5 Newton. So first part, what are the reaction of the partition? The force exerted by the wall on the system is 177.5 Newton. Now B part, the action reaction forces between A and B. Now you are supposed to find out the normal between A and B. So draw FBD of A and B separately. So this is A, and we know that A and B both are rest. So this is normal. The friction force acting alone on A is equal to mu s into n1, and this is 200 Newton. So in order to find out this normal, we can say that net force on the system is 0. So 200 Newton can be equal to n plus mu s, that is 0.15, into normal 1, that is equal to 50. So on solving this, we can say that force exerted normal between A and B can be written as 200 minus of 7.5. So this comes out to be 192.5. So this comes out to be 192.5. The force exerted by B on A is left and equal to 192.5. By action reaction pair, force exerted by A on B is toward right, and its magnitude is also 192.5. Now B part, when the bodies are in motion, what happens when the wall is removed? So clearly we can say that if wall is removed, this force would be removed. So if F1 is removed, the system will accelerate in toward right, and if the system will accelerate toward right, then the normal force between A and B will also change as follows. So if in B part, if wall is removed, So we cannot say the system or the net force on system is zero in this situation, as if wall is removed. So we can say that the force acting on the system can be written as this is A and this is B. The frictional force on A plus B comes out to be 22.5 Newton. So as we can say that net force is toward right, the system will accelerate toward right direction. The acceleration can be find out by F. If we take complete system, for complete system, the net force is equal to 200 minus 22.5. So this is equal to mass into acceleration. So acceleration of the system comes out to be 177.5 divided by total mass, that is equal to 15. From this we can say that acceleration of system comes out to be 11.83 meter per second square. Now once you get the acceleration, you can find out the new normal between A and B. So let's say this new normal is n. So in order to find the value of n, we can use equation for A, that 200, for A we are using the equation that 200 minus of normal is equal to mass of A, that is equal to 5 kg, and acceleration of A comes out to be 11.83. So from this we can say that normal, which comes out to be 133.35 Newton.